sure? You good?
Okay, I'll pass back the rest of these while you guys are taking your in-class assignment, because we do have an in-class assignment. Here's where we're at. Right here, week 5, February 8th. Then next week is week 6. The week after that, we have a lecture on Tuesday, February 20th. Quiz 2 is exactly 2 weeks from today. So 2 weeks from today is quiz 2. And then you hand in your quiz, you have homework due, never. So that means you have a week and a half of spring break, not thinking about stats whatsoever at all after the quiz. With no homework due, nothing. All right, so that's what we have ahead of us. So, where do I want to start today? I don't know where I want to start today. Let's start with the instructions. Okay, I want to refresh your memory. What's due Tuesday for homework? You have your written assignment and your Excel assignment, but I want to give you a big hint. The Excel assignment has many more points for this week's homework than the written assignment. Even though the written assignment is going to take some time because it's monotonous, you got to make all those relative frequency tables, but the Excel assignment is where the points are at this week, so it's a big deal. Due Tuesday, 5 days from today, February 13th. There's our usual materials, tells you which PowerPoints to look at, which textbook pages, which Excel for this week to prepare for the next quiz. Don't forget, keep using the instructions as your guide as to what you should be using to prepare for the next quiz. Which PowerPoints, which Excel documents, which textbook pages. All right, let's look at this week's assignment in Excel. Here's what it looks like. You have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. I want you to do 23 equations to put in where those yellow boxes are. When you get to the bottom, that's an OR, meaning, what row is this, 35? Meaning you can do relative frequencies or you can do percent frequencies. You do not have to do both. You can either do row 35 or do row 37, but you don't have to do both. Most people do both just because they want the practice, but you don't have to. Just do one or the other, it's up to you. We'll get to that in a minute. We're gonna get into a lot of detail here, but this whole project, this whole assignment is all about classes. That's the main part of it. And the data, I wanna make sure you realize, I've had assignments handed in where they thought the data ended right here in column S, but it goes over farther, all the way to W. And you're gonna wanna know how many pieces of data you have, because the number down here, when we get to row 30, which by the way, write yourself a note, row 30 is where all the points are at. I would say at least 36, most likely 42 points out of 100 are just in this row. Row 30. So row 30 is important. And if you notice, there's a cell here, R30. And it's going to count how many you end up. Based on the formulas you put here, the Excel equations, it's going to add up all of the frequencies together. And that total in R30 must equal the number of pieces of data up at the top. Let me repeat that. This is your check and balance. This is how you know if you're doing it right. Cell R30 must equal the number of pieces of data up top. Yes? You can't find what? The assignment? Did I not post the Excel assignment you guys? Is it? Okay, go to assignments, then go to week 5. Oh, okay. And then it should be the second one. All right, so there's your check and balance there. Let's pretend we're getting this started. Right there in cell H7, it's asking you to use an Excel equation to find the mean of that data. This should be easy for you. You've done the mean already. You can just look back, you'll find your example of the mean. Everybody with me so far? Next is cell H11. H11 is asking you to write an Excel equation to find the largest piece of data in that data set. Now, I taught you two different ways to find the largest piece of data, and you can use either one of them. I'm not going to talk about them. This is this is part of it to see if you know what to use here. But you must use an Excel equation to find the largest piece of data represented there. And we learned two different ways. So now, cell H15. It's all about you writing an Excel equation to find the smallest piece of data. And I taught you two different ways. So the smallest piece of data is an Excel equation there. Some people just walked in late, so I want to refresh just because this is so important. I don't want this to happen to anyone because it happens every semester. The data is going all the way from column L over to column W. Don't think there isn't more data off to the right. You scroll over, there's more data. L to W, okay. That's the data we're talking about. Now, I-19. Oh boy. I don't know where you're writing notes at right now, but put I-19, and this is the help you need in I-19. This is where everything starts, right here. This is all about taking the data. You've got to, and listen, what you're learning today is as if we have 1,000 pieces of data, not just however many pieces we have up here. This is a mini example, but you got to pretend as if it's like 1,000. That's why you're using these. You're going to use cell locations in your formulas. You're going to use Excel function equations. Is because as if there's a ton of data. Like I guarantee you, if I put that data up there and you guys stared at it long enough, you can tell me the smallest number. But that's not what this assignment is about. It's not whether you can find the smallest number, as if you can show me you can use the Excel equation you learned in this class to find the smallest number. That's what this is about. So before I go on to I-19, I now want to go to over here, this PowerPoint. Here's what it looks like when you form classes. I want you to see an example of what classes look like. It's in a range of numbers that the data could fit in. And we're talking right now about, remember this data? Oh no, we haven't talked about this data. Hang on. We will talk about that data, but hang on. There's what classes look like. It's $50 to $59. If I went and looked at all this data up here, and I said, hey, how many of this data fit between $50 and $59, it would count it and put it right there and say 2. Look at this next class, $60 to $69. How many fit in there? 13. This is what we're doing for this assignment. You're coming up with those class ranges, and then you're coming up with formulas to count how many of the data fit in each class. Here's the deal. Here's the thing I want to make sure you recognize about these classes. Look at how it goes from 50 to 59. The next one starts at 60 and goes to 69. Each class happens to be size 9, and I'm about to show you how that came about, and you can kind of see it right now. But each class is size 9, and we had to arbitrarily decide what to start our classes off, and we selected 50. Why 50? Because we knew that if we knew the smallest number, that we would know that we want our first class to start at some number that smallest number would fit in. I could have started at 52, but I can't start any higher than 52 because we know the smallest number is 52. But I wanted it to look cool, neat, nice. So I started at a nice round number of 50. 52 fits in the 50 to 59, so it makes sense. Each class then starting at 50, then 60, then 70, then 80, and it looks nice and smooth. That's up to you, how you figure that out. The only thing is, on our assignment, I'm not giving you a choice. Let me go down. Here's where you're entering your classes. But I put the first number in for you. Everyone here, so that we all have the same numbers, we all have to agree to start with the number 100. So your class is going to start at 100. When you figure out what size each class is, you're starting at 100, and you're adding to that, and then you're starting the next one at the next number, you're adding to that, and starting the next one at the next number. Let's go back to this. I want you to look at this so you can compare. What this is called, how these classes are set up, is they're not overlapping. Notice one class ends at the number 59, the next one starts at 60. This is how you set up classes for discrete data. 1, 2, 3, 6, 7, 12, 15, 50, 60, 70. Data that doesn't have decimals. Because there'll be no numbers between 59 and 60, that's because we're using discrete data. We can have that break. We can go from 59 to 60. But if this is for continuous data, that first class would end at 60 and the second class would begin at 60. Because most of the numbers will not be exactly 60. It might be 60.001567 or 59.99924. It's going to be on either side, so we'll fit in one class or the other, and you have to have the numbers overlap. That's called overlapping because we have data that's continuous data, that have decimals involved. Let me repeat that. This is a big deal. When you're forming classes, you don't want them to overlap if you're using discrete data. We ended at 59, we start at 60. We end at 69, we start at 70, the next number. But if we're using continuous data, we would want overlapping. We would end the first one at 60, begin the second one at 60. We would end the second one at 70, begin the second one at 70. See how the overlapping is taking place? That's if we're using continuous data. Now, I want to go back to our homework. I want you to look at this data. You don't have to see all the data, you can just see most of the data. Are we going to have overlapping or no overlapping? I guess what I'm asking is, do you see discrete data or continuous data? Discrete data. So should we overlap, have one number end at a number and the other one start at the same number? Or should we not overlap, end at one number, have the next one start at the next number? The next number, no overlapping, because we have discrete data. So now, let's go back to our classes, so you get this. Whatever you end that first class that I started at 100, and give me a number that's in the 200s that we're going to end it on. This is hypothetical. Give me any number. 298, 230, there's all kinds of numbers. I'm going between the two. I'm going 266. Whoop. 266. This is pretend. This is hypothetical. Because you just told me the data is discrete, what should the next class start at?
267.
Very good. 267, not 266. So I knew it would start at 2 something. I'm filling in the question marks with 67. And then whatever size this first class is, it looks like it's 166, right? From 100 to 266 would be 166. So we must have come up with each class being 166, hypothetically. So we're going to add 166 to 267. So I get my calculator. Oh, come on, where's the calculator? And I would go 267 plus, what did we say, 166 is the class size? Okay, there. So then this one's going to end at 433. So let me go 433. My question for you is, what am I starting this class at?
434.
Very good, 434, very good. You're getting it. Everybody see the process then, right? Okay, I want you to notice as I was creating my classes in row 24, it automatically put the classes all below. Automatically made the same classes in row 29, automatically made the same classes in row 34. I have it all set up that once you form the classes, each of the other 2 sections below will have the same exact classes. All right, so everybody with me so far? So you only have to do that once.
What's I-19?
What's I-19? Is that what you said? Oh, we're not, I-19, we're not there yet. Hang on, we're almost there. We're almost there. I'll go back to it now. I'll go back to it right now. I just want to make sure everybody knows how to form classes. I-19 is going to be what size each class is going to be. We hypothetically just used 166 because I said, give me a number, give me some number. So we used 166. We had 166 to 100, we got 266. We had 166 to 267, we get 433. But that was hypothetical, hypothetical. Here is the real way to form your class sizes. Hang on, right here, right there. You take the largest piece of data, and you gotta imagine there's 1,000 pieces of data, so you're gonna have to come up with an Excel equation to find that largest piece of data. Once you find that large piece of data, you're gonna have to use an Excel equation to look at all 1,000 pieces of data and find the smallest piece of data. Then you're gonna subtract the 2 and divide by the number of classes. You're gonna subtract the 2, divide by the number of classes. That will tell you the size of each class after you round. You're gonna get a decimal, some number in decimal, but round it to a whole number, without the decimal. Go.
So we use the second two numbers that we got in Excel.
Yeah, I was about to say that. You're right. Yes, that's right. That's why in the Excel assignment, you're coming up with an Excel equation to find the largest number. You're coming up with an Excel equation to find the smallest number. And when you get to that cell to tell me what size each class is going to be, you're doing that calculation. Do not enter the numbers, the largest and smallest. Use the cell locations. What the cell location you calculate the largest, the cell location you calculate the smallest. Subtract those two cell locations, then divide by the number of classes, which I'm about to tell you about the number of classes. Go ahead.
I was just gonna ask, like, say, like, from 433 to 267, like, so you subtract, like, 433 minus 267, and divide on how many classes are in between those numbers?
Where'd you get 433 to 267? Oh, right here? Right here? No, don't do that yet. You ready? Let me go back. Hang on. Right there in cell H11 is your largest number. Right there in cell H15 is your smallest number. So this is going to use those two cells divided by the number of classes. Now, before I tell you the number of classes, I want to make sure you understand how to determine how many classes to use. When you have a bunch of data, most classes, when you break the data into classes, most of the time there's only between around 5 to 20 classes. 5 to 20. Here's the rule of thumb. It is subjective as to how many classes you want to use. It's up to you. But the rule of thumb is you should always use less classes based on having less data. You should always use more classes based on having more data. So in our case, I don't think we even have 100 pieces of data. So we should only be using 5 or 6 or 7 classes. But if we had 1,000 pieces of data, like I want you to imagine this project is for, we would want to use 18, 19, or 20 classes maybe. To determine, you almost can't use too few classes, but you can. But to determine if you're using too many classes, after you've done all this, and let's say you accidentally used too many classes, let's say you said, I'm going to use 10 classes, when maybe you should be only using 7, you're going to have some of the classes that have 0 pieces of data in it. And if you have classes with 0 pieces of data, you're using too many classes. That's the main indicator. Matter of fact, here it says, let's see, use enough classes to show a variation in the data. Do not use so many classes that some contain only a few data items. Well, I'm saying if any of them have 0, if you have a class that has 0 pieces of data, you probably have spread the classes too far, and you have too many classes. Now, with that said, how many classes should we use with our assignment that has less than 100 pieces of data? Closer to 5 or closer to 20?
Closer to 5.
Closer to 5. So for the assignment, so that we all get the same numbers, it says right here, you write an Excel equation using the Excel cells from above to take the largest minus the smallest, but then divide by 6. Let me repeat that. We're all going to use 6 classes. I could have used 5, but I wanted to use 6. Because you're right, we don't even have 100 pieces of data. We probably should use 5. But we're going to use 6. 6 classes. So now, hopefully you have just written down what you think should be put in cell I-19. Does that answer your question about I-19? Your sister had a question? Did she have questions today? Well, listen.
Oh, no, I didn't.
No, you didn't what?
Have a question?
I-19? Who asked about I-19? Oh, does that answer your question about I-19?
Sure.
Do you know what to put in it?
Yeah,
Do you guys know? Did you write down what to put in it right now? I can write the formula right now. Right? Everybody wrote it down, didn't they? Did you write a formula down? Equals, what's the first thing, what's the next character you're putting? Equals what? Equals?
I got 149.
Largest divided by.
What's the next character?
Large.
Nope.
Max.
Equals what?
Max.
No, not in this cell. I want you to use the cell locations where you already have the largest number. H. No, that's I just want the H. So equals H. We just started I-19. Equals H. Don't forget, you're writing no, matter of fact, you made a mistake. It's not going to work. It's not equals H. equals parentheses.
Parentheses.
That's what I did.
Equals, did you say parentheses? Thank you. Sorry, I missed it. You gotta say it with more confidence, like you're sure, like you're sure.
Speak up.
Parentheses, then the H. Okay, everybody see where I'm going with this?
Yeah.
Without that parentheses, you'll have the smallest number divided by 6 before it gets subtracted because of order of operations in math. And that's why you've gotta have those parentheses on that subtraction, because it's gotta be subtracted first before the divide. Okay, that's about it on that hint. Everybody knows what to do there. Now, let's go back to hypothetical again. Let's pretend, I'm gonna throw the number here since we already came up with one, that came out to be 166.255. We're gonna round it to 166. I want you to use just a number, the rounded number here, to then add to 100. And then you're gonna manually say, what's 100 plus 166, or whatever number you get, and you're gonna decide then what the end of that range is. We went with 266, hypothetically, because we're using 166 as a demonstration. Believe me, your answer is not gonna be 166. I don't know what it is, but it's not 166. The odds of us
149.
guessing a number and it being it are so slim that I'm willing to bet there's no way it's really 166. So let me keep going. We then start at the next number and add 166. We then start at the next number and add 166. You're gonna have 6 classes. So you have all your numbers across there. Everybody still with me, right? Okay. Now, let's look at the demonstration as to how we got the classes in this one. See all that data there? We decided to go with a small amount of classes. Matter of fact, we decided to go with how many classes? 1, 2, 3, 4, 5, 6 of them. And that's even less data than ours, I think. And we went with 6 classes. So, here's what we did. We found the largest number of the data. Stare at it for a minute. I see 105, I see 109. 109, there it is. Then we looked for the smallest piece of data. Stare at it, help me out. 52, I think, wasn't it? But I don't see it. Oh, top row.
I see 57.
52 in the top row, 2 over from 57. So we now know the largest from the smallest. 109, I'm not gonna write on there, I don't want the other class to see it. 109 minus 57 divided by, they decided on 6. How do we know how many classes to use? It's arbitrary. It's up to you how many classes to use. But the rule of thumb is, the less data you have, the less amount of classes you have. And if you, more data you have, the more classes you have. But if you select too many classes, you'll have some classes with no data that was fell in it. That's when you know you picked too many classes. But for this assignment, we're all going with 6 classes. So now, 109 minus 52 divided by 6 gets you 9 point something. I think that's wrong, it doesn't matter. Round it to 9. Why did we start at 50? We knew 52 was the lowest number. We wanted it to look clean. We could have started at 52, we could have started at 51, we could have started at 50, we could have started at 48. But here's the deal. You gotta make sure whatever you start at, that when you get to the end, the largest piece of data fits in the last class. Let me repeat that. Because if you started the first class with too early of a number, if I would have started with 49, look what would have happened. We would have ended at 108. Instead of 109, we would have ended at 108, and the 109 had nowhere to go. And that's when we blew it. So that's what you gotta watch out for. You wanna start your first class at a number that makes sense, that your smallest piece of data fits in. And after you put all your classes together, you gotta look at the largest piece of data and ask yourself, does it fit in the last class? And if that's true, you're probably good.
Can the largest number be the last number?
It can be, yeah, it happened here. See how the 109 happens to be 109? Right, but had we started at 49 at the top, we could have started at 52, we would have ended then at 111, I think, right? 111, because if we started at 52, so the 109 would fit easy, but the 52 would have been just fitting at the beginning. So you just gotta be careful. If I were saying to you, everybody gets to pick their own first number, yeah, we can get a whole bunch of different answers, but hopefully, there's a lot of right answers. As long as the first piece of data, the smallest piece of data fit in your first class, and the largest piece of data fit in your last class, I would have counted it right. As long as we were all going with 6 classes, you couldn't get that part wrong because, if I were allowing you to pick how many classes, yeah, someone in here may have picked 12 or 15 classes, they'd have some with zeros, and that would be wrong. That's how you know you picked too many. Go ahead, Ali.
So when you get the class size, and it says create 6 classes,
Yeah,
ranges,
round that class size you just
you
calculated.
round it
to up or down appropriately,
Okay.
then add that number to 100. There's your first
And
class.
that's your first number.
That's your first class, then go to the
Okay.
next number for the next class.
Right.
Everybody hear that? So he's calculating right now what the range should be. He's appropriately rounding it, hypothetically 166, because that's what we're using. He's now adding it to 100 to do that first class. Now he's gonna start the next class one digit above, add that same number to that to get the end. Go one digit above.
So hypothetically, if it was.
Don't give me the real number.
No.
Okay.
Let's say it was 166.17. You round it to 166.
Perfect,
Okay.
because the next digit's a 1.
Right.
Yeah, so round to 166, if it were 166.17 or 166, what, 166.49, what number would we use? 166 still, because it's still a 4. 166.51, now we're using 167, get it?
The practice, or not the practice, the example that you showed us, the 9.2, I got when I divided.
Yeah, I know it's off, just pretend it's 9.2.
Oh, okay.
Okay, because I want this to work out. Alright, I know I changed that finally one year when I wanted it to work better. So we rounded to 9, we started at 50, we added 9, we started the next one at 60, we added 9. Look how clean it looks by starting what we started at. But I took a risk, because when I got to the end, 100 added 9, it finished at 109, the largest piece of data is 109. Look how close I was to not being able to fit that in there. Had I started one number short, if I started at 49, we would have blown it, had to redo the whole thing, because the last number wouldn't have fit. So there's your check and balance. Now that you got that row all figured out. Hang on, let me see, what was I doing? All right, now you've got to turn, hang on, let me go back to the, I want to go back here. Okay, we're skipping row 30 for now. We're skipping row 30 for a minute. Row 30, where all the points are, is where you're writing Excel equations to count how many pieces of data are in each of those classes. So see how I got the 100 to 266 there, because that's the class we entered up above? This, right there in that cell, E30, we're gonna be writing a formula that counts how many numbers are actually between 100 and 266 in the data. Still with me, right? After each of those are counted, right there again, R30. R30, hopefully you got your notes. R30 must equal the total number of pieces of data up top. That's how you know you did the row 30 correctly, is if R30 equals. You most likely did it correctly if R30 equals the total number of data. Now, all right, you with me? Total number of data up there. Like right now, if I went up there and counted all that data, L all the way to W, all that data, it should be, however many pieces are up there, should be exactly what shows up in R30. That's your check and balance. But I want you to use R30 in your calculations below. Because below, I want either the class relative frequencies, which is row 35, or each class percent frequency, which is row 37, using cell locations for your equation. So, for example, I'm right here, this would be equals, this would be how many are between 100 and 266. What is that? E30?
Yeah.
Divided by, well, how do I figure out what the total number of data is? Oh my gosh, there it is, R30. Okay, I just gave that one away. I can't believe I did that. Get that off there. Anyway, see what I was getting at? Using cell locations to calculate those relative frequencies or percent frequencies. You can do either row. The difference in the equation is that the bottom one, you gotta multiply by 100. That's the only difference. The top one, you're just dividing. The bottom one, after you divide, multiply by 100. That's the difference. You can do either row or both, but I'm only grading one or the other. All right? Now, I want you to show you on the PowerPoint how we're gonna take these classes. This, by the way, is the same as reviewing relative frequency and percent frequency way back in week 1. The only difference is that we're using classes instead of just a plain number. So, let's say I want to I add them all up, there's 50 pieces of data. 2 of them are between $50 and $59. So 2 divided by 50, there it is, 0.04. Next, The 60 to 69, there's 13. So to turn into relative frequency, 13 divided by 50. There it is, 0.26. Everybody get this? I mean, it's just like relative frequency with data points, but instead we have classes. Go ahead.
How do we get the amount, like the number in each class?
The 2, 13, that's the last part.
Oh.
That's the last part. You're gonna learn how to do that row. That's where all the points are, is writing those equations to figure out how many are in each class. But once you have the number of how many is in each class, you gotta skip down to the next part, which is form, relative, or percent frequencies. And I wanted to make sure you remember how to do them. What if I wanted the relative frequency between 80 and 89? How would I calculate it? What times divided by whatever?
89 minus 8.
There you go, 7 divided by 30.
What?
7 divided by 50, not 30. 7 divided by 50, which happens to be, 80 to 89, 0.14. So the other one is 7 divided by 50, also 0.14. Now, if you wanted to turn it to percent frequencies, you just multiply the relative frequency by 100. Just take the decimal 2 places to the right. 0.04 is 4%. 0.26 is 26%. 0.32, 32. 0.14, 14. 0.14, 14. 0.101, 10. Everybody understand how to do the last section, what I'm asking for on this part of your homework, which is where most of the points are, your Excel part of the homework this week. Everybody understand what I'm looking for lines 35 and 37? Can you do relative and percent frequencies for classes? Yes, yes, yes. All right. Now, here we go. Oh, wait.
So you do the percent and for the relative, it's the same thing?
But the percent frequency is 2 decibels to the right. You get to multiply by 100. So you got an actual. If you decide to do that row instead of relative, do percent, write your equation, use the cell locations, then put times 100. Move the decimal. All right, real quick, we're taking a break. Intermission. You ready? This is intermission. We're taking a break. If the mean is 12 ounces, standard deviation is 2.6 ounces, show detailed work to calculate the probability of 11.2 ounces or less. You have been asked by the president of the company, you work to calculate the probability that one employee out of a randomly selected list of 4 employees will leave the company in the next 12 months. Traditionally, the company has turnover of about 12%. This means that 12% of the employees leave each year and the company spends money to replace them. I just read 2 problems. Which one's a normal probability problem?
First one.
Why the first one? Why the top?
Because it has a mean and standard deviation.
Because it has a standard deviation. Very good. What kind of problem's the bottom problem? Binomial. Because it's asking you for the probability of a certain of a number out of a randomly selected number, 1 out of 4. And and it's binomial because either they're still employed or they're not employed. There's either a success or not a success. That's binomial. Good. Just want to make sure we're preparing. We're just keep getting ready for the final exam. All right, let's go back. So now you're going to learn these. I'm going to start with sum. I know all of you have used sum before. You've seen sum before. Right now, SUM, parentheses, B8 B21 equals SUM. It's looking at all of this data from B8 to B21, and its sum is telling Excel to add them together. Add the numbers together, but look, there's letters. A, B, E, E. Where's the other one? A, B. 3 of the cells have letters. Excel will ignore it because you're using the word sum. It knows to add the numbers together. If I added all the numbers in that column, it'd be 3,321. Everybody knows how to use sum. Everybody's used it before. But now, this is count. C-O-U-N-T. Equals count, parentheses, the range of where the data's at. It's going to look at the data and count how many of the cells have numbers in them. So there's how many cells here altogether? There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 cells. It brought back the number 11. It's saying that out of those 14 cells, 11 have numbers. 3 do not have numbers. 11 have numbers. Count A. Count A goes, and notice the range I put, B7 to B25. I went down and past the data. I'm including 14, 15, 16, 17, like 18 cells. But it brought back the number 14, because what count A does, it counts how many cells have anything in them. Anything. Letters or numbers or characters. That's the difference between count and count A. Let me repeat that. Count will count how many of the cells in the range have numbers in them. Count A counts the number of cells that have anything in them, a character of any kind almost, I think. Let me check my notes. Anything? It's not empty. That means anything. Okay, ready? Count, it counts the number of cells in the range that have numbers in them. But count A counts the number of cells in the range that have anything in them that are not empty.
So as long as anything.
Anything. Could have a dollar sign, could have an asterisk, a comma. If it has something in it, it will count it. So I have I highlight 18, from B7 to B25 is about 18 cells, and it brought back 14. Only 14 have something in them. Go ahead, what was your question?
I said, what do we do with the count here? Like, how would that help us?
I never use it.
Well,
But-
do we need to know it for like the exam?
Well, of course. If I'm talking about, we gotta know it, right? We gotta know it for the other class, how's that?
Does it just count cells with characters or characters per cell?
No, just cells with characters, not how many characters at all, no. So out of those 18 cells, it was said 14 had them. Now this is count if. You got that additional IF on it, equals count if. And this is where you tell it a range of cells, but you can literally tell it what to count. You can tell it like what numbers to count. So in this case, I'm saying, matter of fact, hang on a minute, I'm gonna change it. Right now it's counting how many between B8 and B21, how many in those cells happen to have numbers greater than 30, not equal to, greater than 30. For example, the second cell, 43, there's one of them, 432, 122, and so on. It says there's 8 of them greater than 30. So it's like count, where it's counting the cells with numbers, but you can tell it what to count. So you got a comma after the range of cells, and then you got to use these quotations. Everybody see the quotations? Let me read it to you. Equals, COUNTIF, parenthesis, B8 dot dot, or colon, B21, comma, quotation greater than sign 30, the number 30, quotation, parenthesis. Now watch, I'm going to change this. Let's instead change it to equals, so the greater than's gone, and I'm going to put equals 43, because I can see 43. Now, how many 43s are there? If I did this right, inside the quotation I have an equal sign 43, it should say 1, I only see one of them.
Yeah.
There it is, 1. Now I want to show you a little trick about count if. I'm going to put this time equals AB. Let's see if it counts letters. I don't remember if it does or not. Says there's 2 ABs. Is that true? Is there 2 ABs?
Yes.
Oh, yeah.
Oh, look at that. It counts letters too. It can count anything. How crazy is that? You can literally use it to write programs with. Let's see, I want it to count now. Let's count, let's see. Okay, let's do 43, but this time let's do greater than or equal to. So I put a greater than symbol and then an equal symbol. Oh, and what did I say, 43? So now it's gonna count 43 as well as any number above 43. We should get like, I don't remember what that is. 8, all right? Let's try 23. Oh, there we go. There's 11 numbers that are 23 or larger. I see a 23 there, and a 23 there, and a 23 there. There's 3 23s. So if I take the equal sign out, this should go from, wait, what was it again?
11.
11. Okay, it should go from 11 down to 8. If I take the equal sign out, let's show. So it's just going to say greater than instead of equal greater than. And sure enough, there it is back to 8. So you can see how it count if. Can count all kinds of different things in different ways. Matter of fact, this time, I'm going to have it count how many numbers are less than equal to 23, which should say 3, because 23 I think is the lowest number, right? And there's 3 of them. Let's see if I got it right. Sure enough, there it is, 3. Count if B8 to B21 less than equal 23. Now, if I get the equal out of there and just put less than, it should say 0. And sure enough, it does. Because there are no numbers less than 23. Okay, you understand how to use it. Now, let's go a step farther. This one is combining two COUNTIF statements. And watch what it does. It says equals COUNTIF B8 to B21. How many numbers are greater than 20? Let's count how many numbers are greater than 20. They're all greater than 20 that have numbers in them, because the lowest number is 23. So how many have numbers? There's 11. So right now we're at 11. Here we go. But then it says, let me get to the equation. Then it says minus COUNTIF B8 to B21. How many are greater than 54? Well, how many are greater than 54? Not that one. Not that one. There's 1. There's 2. There's 3. Not that one. Not that one. 4, 5, 6. And that's it. 6. So because I put how many of them are greater than 20 minus how many of them are greater than 54, there's far more of them greater than 20 than there are 54. Subtract the 2. That's how many are between them. That's how many are between them. Does the light bulb turn on for anyone? Yes? Yes? Do we understand how to do row 30, where all the points are? All right? Be careful, because you may need to use equal signs sometimes. Watch what happens when I put, because there's a, I'm going to change this to 53. Let's see if it changes the answer. Still 5. Still 5. I changed that to 53 because watch what happens if I put an equal sign with the 53. It's not going to be 5 anymore. Now it's going to be, watch what happens, 4. Because we included 54, we included 53 as one of those numbers to be subtracted. Yes?
Did you put a minus sign between the COUNTIF formulas, or did you just put?
No, there's a minus sign right there. You can barely see it. Minus sign between the two COUNTIFs. You start with an equal sign and a minus sign between them. But the most common mistake here is that a lot of people think the bigger numbers on the left and the smaller numbers on the right, but that's not true. You want the bigger count on the left and the smaller count on the right. That's why the smaller numbers on, or the smaller numbers on the left. That's why the 20's on the left, the 53's on the right. Because there's far less numbers above 53. That's how you find that how many there are between. All right, hopefully the light bulb turned on. I want to go back to the homework now. Put it all together for you so we can get past this. Let's hypothetically say that this is between 100 and 266. You're going to go equals count. Now I'm stopping there. Because I don't know what to use next. I don't know if this is count or COUNTIF. I don't know if I'm subtracting another one. I don't know. That's up to you to figure out. But based on this lecture and this recording that will be posted, you should be able to figure it out what to do now on line 30. The most common mistake here is some people think you should use equal signs, some people think they don't use equal sign, and you got to say to yourself, do I want to count all the numbers between 100 and 266? Do I want 266 to be part of the group that's between the two? So that's when you got to say to yourself, do I use equal sign or do I not use equal sign? Experiment with it, but when you get to the end, right over here, whoop, 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 this is automatically, let me put that back to nothing again. This is automatically adding up all of your row 30 equations. And that number at the end of, when you get the last equation done in R30, should equal the number of pieces of data you have up there. That's pretty much the key to saying, I think I probably did it right. When those two equal. Everybody understand what I'm trying to get at for this check and balance? And then you're going to use R30 as part of your equation when you do the relative frequencies below. Any questions about this assignment? This is one of your hardest assignments you've had this semester. I would attack this today while it's fresh in your mind, maybe, at least get some of the hard parts out of the way, and then go back and review it.
Do we write it on paper?
Oh, I'm sorry. This is the only one you're handing the Excel spreadsheet in. I apologize. I forgot to say that. Thank you. I better put an announcement up to remind everybody. You don't have to write this one all out. Wait, do you?
Wait, because then we how about the written?
The what?
The written.
Yeah, the written part you write now.
So it'll be like returning one.
You're handing in a written assignment, and then you're gonna email me a spreadsheet. Right, I'll put an announcement up, I hope I remember, I'll put an announcement up, don't forget this week's assignment, you are emailing a spreadsheet, what I'll put in the announcement. Gosh, why did I do that? Here's the thing though, if it's late, if you're late, you still gotta handwrite all this out, all those equations. We will do it that way if it's late, cause you can't just copy and paste it, that wouldn't be fair, all the work everyone else put in that, handed in on time, after I post the answer.
Wait,
All
this
right.
one, are we turning it in on it?
You're gonna hand in an Excel spreadsheet on this one.
Right, we're not
Literally-
turning it on paper.
You're not gonna write this
We're
one on
gonna send
paper,
it
you're
to
writing
you.
the written part on paper though.
Yeah, yeah.
Okay.
We're gonna send you this for on
Yeah.
email, right?
We're
Yeah.
gonna email it to you or?
You're gonna email it to me
Okay.
before class starts on Tuesday.
Hey,
Yes.
do you know how to solve it or no? Are you using it? I mean, I don't understand the other parts, but for the rule period, is it equal or no? Equal count or just count?
Yeah, let me bring that example up. She's asking about this example right here. No. Right here, right there. This, I have it at 20 and 53, I'll switch it back to
I know, but the
54.
thing is, I'm trying to say there's only
There,
one
she's
cell.
asking about this one, go
If you
ahead.
go on there, it's telling you to solve it, basically count how many numbers, but use it.
Yeah, like for example, this first part is counting how many numbers are above 20. And if you, I went through there and counted them all, and there were 11 numbers, because they're all above 20, there's 11 numbers
You know what
there.
I mean?
There's 14 cells with 11 numbers, they're all above 20.
But,
The second count is counting how many numbers
For each class
are
we have
greater than or
one
equal to
side.
54, which there are 6 of them greater than or equal to 54.
Oh, yeah.
So there's a minus sign between them, so it's taking 11 minus 6, there's 5 between them. There's 5 numbers between 20 and 54. You get it? If you go and look, count all the numbers between 20 and 54, you'll see there's 5 of
Wait,
them.
so why do you have 547?
Because you eliminate all the numbers above 54 by subtracting those 6. Okay. That's
I'm
probably
positive
absolutely
about this
true, yeah.
exam though.
Everybody hear that? If this were continuous data with a lot of decimals, you wouldn't have an equal sign in your count statements.
What?
You wouldn't use an equal sign. We're not using continuous data, we're using discrete data, so just ignore what I just said.
Okay.
For the assignment at least. Okay? No, continuous, you would not, I'm sorry.
No.
You wouldn't use equal signs. No, you can use equal signs with discrete. With discrete, because nothing's gonna land right. at
Wait, we can use
54.
equal sign with a discrete?
You can use equal sign with discrete if you want, yes.
Where? Beginning or in the
It's up to you. It's up to you. You have to decide whether you even wanna use it at all. You may not want to.
Okay,
Here's the deal. On the assignment though, if I had, hang on. Let's say I had one of my numbers, I'm writing it right here, trying to figure out how many between 100 and 266.
Yeah.
But I notice up there that one of the numbers are exactly 266. If I don't use an equal sign, it will put that in the next class instead of that one.
So we need to use the equal, right?
If you think there's gonna be a piece of data that's exactly that number, yes.
Okay, well, I have a question. Over here,
Huh?
over here.
But if you want 266 to count in the first one, you wouldn't use an equal sign. So it all depends.
No, so if I wanted to count, I use the equal sign?
It's up to you. It depends. Like for example, you may use equal sign in the first part, but not the second part, for example. Right?
No, I do need it to count, so I'm gonna use it.
I don't know.
Okay, so I have a question. So see on the other assignment, like the one that you were just solving for it?
Yeah.
It has like 14 cells that you used for the
Yeah, let me go back.
Yeah, well
For
that
this one, yeah, there's 14 cells here, yes. But the first one says how many of them are greater than 20, and that's only 11 of them are greater than 20.
Yeah, well.
3 of them are letters.
Yeah, well, I'm not talking about that part. So see how you have like 14 cells, and you're asking to like use the count formula, whatever, the equation to find whatever. On our assignment, we only have 1 cell.
No, you have,
No, can you go back to our assignment?
yeah, you are supposed to be using, you're supposed to be using all of these cells up here. There's your data up there. All the way over to column W. You get it?
Okay.
You get it? Did you get it? Yeah, there's not just one cell of data, there's a whole bunch.
Okay.
Okay, all right. I'm making sure you had it. All right. And now, let me review again. again with row 35 or 37, use cell locations. Don't just put numbers there. Use cell locations such as, you know, E30, R30, so on like that.
President,
Yes.
for row 24, did you say that the beginning, has to be the lowest amount and then the end has to be the largest amount?
Yeah, the smallest number has to fit in that class, the 100 to whatever. But you gotta start at 100.
Wait, it has to be the same number from the.
No, the smallest number, whatever the smallest number is that you get down here, where's the smallest number? Right here.
Right?
Right there, whatever number that is, has to be between these two numbers.
So then you would add that number?
No. You're adding whatever the range is from, what is
Right,
that?
149.
I-19 is, whatever that is what you're adding to 100.
Okay, so it's 100 to 240.
Okay, let's say this is 100 to 250.
Right.
Does the smallest number fit between 100 and 250? Then you're fine. It
Oh,
will.
okay.
Yeah, the smallest number.
Oh,
will.
okay.
Yeah. Then you're fine, as long as the smallest number is between 100 and 250, if that's what you went with.
Oh, and so they both have to be.
All right, we got a little bit more we gotta learn today, you guys.
Under 999, good.
I want you to look at this. Hey,
We use the equal sign.
we got a little bit, we got one more thing we gotta learn before we go on. We gotta get the in-class assignment, we gotta learn this one last thing. We got 5 minutes, you ready? Randomness. I need all your attention. Randomness. You need to understand how important randomness is in data collection. This is such an important theory. Because with randomness, the whole point of it is that every item in the population, all the things that could be in our sample, it has the same and equal chance to be part of the sample. I want you to look at this. You're managing an auto repair place, all right? And you're trying to put together a sample of 50 invoices, like that. Here's the deal. I'm at the auto repair place. I got 4 cabinets here. 4 cabinets full of invoices. Luckily, as I was putting these invoices in, as we were doing business for the last year or two, whatever this is coming from, I put them in order and numbered them. And we happen to have 900 invoices in these cabinets, in order. I gotta figure out a way to pull 50 out of these 900 with this theory. The theory is, every one of the 900 have the same equal chance to possibly be one of those 50. And I gotta, every one of those 900 have to have the same equal chance of possibly being one of the 50 I'm about to randomly pull out to figure out the average amount of invoice of these invoices. I wanna know the average. And I'm gonna use a sample of 50 because I don't have time to add all 900 and divide by 900. I'm gonna add 50 of them. Now here's the deal. I wanna show you something. I think I forgot to open it. Did I? No, look at this. Here, I wanna take you back a long ways, you guys. Hang in there with me. I'm taking you back years. I'm going back a long way. In the old days, so that a class, a statistics class, would all have the exact same numbers to use to figure out which of these 50 we're pulling out, we would use what's called random table books. When you took stats, you had to buy this little thin paperback book along with your regular book that had nothing but pages that looked like this, just pages and pages of random numbers. And then all of a sudden the professor would say, so that we're all gonna use the same numbers, let's randomly select a column. How many columns are there? Like 12 columns. You guys pick a column for me. 1 through 12, pick a number. 8, we're gonna go with the 8th column. 1, 2, 3, 4, 5, 6, 7, 8. Tell me the number on top of there so we all know which is the 8th column. What do you guys see?
2, 1, 5, 6.
Oh, okay, I'm on the wrong one then. 1, 2, 3, 4, 5, 6, 7, 8. 81639?
Yeah.
Is that it?
Yeah.
Okay, that's the column we're using. Everyone agreed to it. So now the professor would say, okay, what's the amount of digits for the largest numbered item out of our invoices? I said they're numbered 1 through what? 900. So how many digits are used on 900? 3 digits. We're going to use 3 digits from column 8. Left or right? Give me a left or right. Anyone? Left or I heard right first. We're going to use the right 3 digits from column 8, and we are going to pull these invoices out based on this random choice of digits, and we keep going. If we have a number that repeats the same number, or if we have a number that's over 900, we skip it and we keep going until we get 50. For example, tell me what the first invoice is I'm pulling out. I got 639. Do we have a 639? It goes all the way to 900. I'm going to that drawer. 639, got it. What's the next one I'm pulling out?
699.
No.
No, 973.
Oh, wait, what is it? I'm sorry, it is a 6. 615, thank you. Same drawer, that was pure luck. Pulling out 615. Next.
318.
318, you're getting it.
Yeah.
Okay, we're all pulling out the same number. But here's my question is, this page was random. They picked column 8, random. You guys said right-hand side back in this area, random. All random. Did all 900 invoices have a chance to possibly be one of the 50 that we chose? That's how randomness is done. That's what you've got to say to yourself. When you're trying to collect data, you got to say, for this data to speak about all of these invoices, for these 50 to tell me about all 50 of them, every one of the 50 had to have an even chance. The same chance as the other ones to be that 50. I'm going to do what's called inference. Infer what I learned about these 50, about all 900, and I'll bet I'll be pretty close as long as I truly used randomness to pull them out. Now I want to make sure you realize something. There were a million different ways we could have decided how to pull that 50 out, and each of them would have had the same even chance. I just wanted to show you one possible way, and now I want to show you one other way. Are you ready? Excel has an equation called RANDBETWEN, ran between. It says it will pick any random number between two numbers you tell it to. I'm saying equals ran between parentheses 1, 900. It will pick any number between 1 and 900. Every time I hit enter, space enter on a cell, that's going to change. You ready? Take 783 out of the drawer. Take 473 out of the drawer. Take 249 out of the drawer. Take 609 out. Take 79. Take 703. Take 185. Do you get it? We now have another way to randomly. Excel has no idea what we're even doing. It's just giving me random numbers between, I told it between 1 and 900. Every one of them had the same equal chance of possibly one of those 50. Yes?
Can you show the equation one more time?
You ready? Equals ran between. By the way, we're going to cover this again later in the semester. I just wanted to bring it up now because we're talking about randomness. RAND between, and then 1, 900, because these were numbered from 1 to 900. We got to do our in-class. You ready? Let's do it. I'm going to pass the rest of these back while you're working on the in-class. Let me explain this to you so you don't freak out. Here we go. You guys ready? Look at that data. Using the spreadsheet picture above, manually calculate the size of each class for 5 classes. Manually calculate the size of each class as if there's 5 classes you're going to do. Then, start your first class at the number 120. We all start at the number 120. Figure out your size of class, round your size, whatever class size you're going to have, round it, okay, appropriately, add it to 120. Don't overlap. Start the next one, the next number, add it that then. Start at the next number, add it. Do it for 5 classes without overlapping. Everybody get this? All right, let me stop the video so we don't have to edit it. And we can just put it up the way it is. Hang in it.
Yeah,